Ready. Ready. Ready.
Hello, welcome to Enlightning. It's so good to be back after a little KubeCon break. I'm here now with Richard Case, who's going to teach us today about Cluster API. Rich, tell us about yourself, please.
Hey, Whitney. Thanks for having me.
So glad to have you.
Richard Case. I work at SUSE as an engineer, specifically on Rancher and cluster provisioning. But more relevant to this, I am a maintainer of the AWS and GCP cluster API providers, and I've also worked on a number of other providers and created them from scratch, such as the micro VM cluster API provider and the RKE2 provider. Outside of tech, love all things Lego, and you can't see on this, but I've got Lego all the way around me. Slightly addicted to it, which my wife hates, but I love it. So.
It seems like as far as addictions go, it seems like a pretty harmless one. But what do I know?
I think so, but yeah.
So I'd like to get to know you a little more before I dive too much into technical things. But my first cluster API question is, so you said you're a maintainer on like GCP and AWS API provisioning. So are those built on top of cluster API, or is that like those totally different things?
So they work in tandem. So Cluster API has two parts. So it has the core Cluster API part, which then is extended via Cluster API providers, and providers sort of enhance and provide the extensibility capability of Cluster API. So
Cool.
they work together.
Excellent. Maybe we'll revisit that idea a little more once
Sure
I'm
we will.
behind the light board. Cool. So, were you at KubeCon in Amsterdam?
I was at KubeCon. I couldn't go for the whole time, so I had to go for 2 individual days, not consecutive days. That would have been easier.
Yeah.
But 2 days.
Where do you live?
I live just outside of London, so
Okay.
literally it's only a 45-minute plane journey.
Okay.
But still painful.
Yeah. I am. I'm getting to be a little more well known in the space, which is cool, which is exciting. But something happened to me this time that I wasn't prepared for, which is after KubeCon was over, people kept asking me what I thought about KubeCon. Like, let's do KubeCon wrap up. What's new at KubeCon this year? And I was just caught, I guess, with my pants down is the expression, because I was, well, for one thing, I gave a talk. Did you give a talk this time?
I did. Yep.
Yeah, what was your talk about?
Funny enough, it was on Cluster API, and specifically on the provider side of Cluster API.
Oh, nice. Cool. So I gave a talk. So number one, my first, like all of my like worry and concern, I can't even really be social with my whole heart until that talk's done, because I'm just really like concerned that I just really want it to go well. I'm very eager about wanting it to go well. And then second of all, once it is over, I'm not one for consuming other talks, because I feel like that content is available for me to find later. And what is in front of me now is opportunities to make like real human connections with other people who share interests with me. So that's what my big focus is just making friends and networking. And so then when it happened at KubeCon, like at the end, someone's like, come to my booth and be on the podcast. And I didn't know it was going to be a KubeCon wrap-up podcast. They're like, so what did you learn? What's hot? And I was just like, I have no idea. Like, I learned this person's really nice. I learned this person's, yeah. Like, I'll tell you like personal things about all my friends, but I didn't like technically. So I guess what I learned was, well, two things. I haven't landed on one side. So one thing is I could just pay more attention to what's like, oh, well, I see a lot of people are talking about AI and machine learning, or like, I don't know what they're saying at all, but I'm at least like paying attention to the keywords. Or the other side is for me just to say, I'm a new learner. I feel like my place in this space is to get to understand things that already exist more deeply and how they work together. And I don't really see myself as like a bleeding edge cloud person. And I think that's okay. So I may go with that story. I haven't decided yet.
Yeah, I'm sort of with you. I think for me, the best part of KubeCon is getting to meet people, real people, especially in like an open source project where people are all from around the world. It's like one of the only opportunities where you actually get to meet them in person. And I think it's a wonderful thing. It's just KubeCons are just so big these days. It takes forever to walk from one side to the other.
Yeah. One of my favorite experiences at KubeCon was I helped volunteer at the Build Packs booth in the Project Pavilion. And that was just such a blast. It's a blast to talk to people who are curious about Build Packs, but it's also just a blast to like see everyone else at all the other projects who I'm getting to know through Enlightning. And yeah, that was so fun. Yeah. So we have some friends here. Bucky Buck says, howdy, Whitney, Richard. Thank you so much for coming. And Fuel Snobel's here. Hi, Fuel Snobel. Missed you. Fuel Snobel's here almost every week. He's a buddy. He is actually a guest on the show once too. So I kind of made that about me, but also I kind of wanted your opinion because I feel like it's kind of a bold move to say my stance on what's new at KubeCon is I don't care. I want to feel, yeah. What do you think?
Yeah, I think there's definitely two schools of thought. I'm definitely in your camp. So when I go there, I spend most of the time walking around and visiting booths, talking to people. I especially like the co-located events that happen prior to KubeCon, especially the Contributor Summit. So the Kubernetes Contributor Summit. So people that contribute to Kubernetes and its sub-projects all get together. And there's some other talks. So that's always pretty interesting because they also have like an unconference format, so you never know what you're going to end up discussing. But I also think it can be hard to get into the sessions at the moment, even if you wanted to go. I wanted to go to one that was on Prometheus and real-time incident response, but literally the hall was full 15 minutes before, and they were counting people in and out. So you have to be there early.
Yeah, I knew they got full, but I didn't know they got full like 15 minutes before, and it was that intense.
Yeah, so, crazy.
Yeah. So speaking of contributors, I think it probably segues well into our next section. So I'm about to move behind the light board. Oh, we have Kormaju's here. Hello. Thank you for coming. Okay, so I'm going to drop into chat. I'm going to drop on a link to Cluster API. And this you said is a book. It's not quite the docs. What we explained this link?
Yeah, it's the documentation site. We call it the book just because that's where it lives in the source repo. And it's a mixture of documentation, reference, but actually behind it, you obviously have the repo, the main Cluster API repo that you can also visit as well.
Okay, cool. And then, so as far as being a contributor to open source, you taught me in pre-show that there is a Linux Foundation program for mentorships to help people become contributors. And so I'm linking to that, and I would love for you to explain it to us. But before you do, I do want to ask chat, y'all, are you how are you provisioning clusters right now? Like what tech are you using? Are you using a tech or doing it manually? What is there anything in particular that you're hoping to get to learn about today that we should definitely cover? So that's a question for chat. And then my question for you, Rich, is I want to hear all about this mentorship program and how to get involved.
Cool. So the LFX mentorship program, so it's run by the Linux Foundation. It's not specifically for Cluster API. It's for any of the projects that fall under the umbrella of the Linux Foundation. And Kubernetes is one of those, or CNCF and Kubernetes is one of those. So you can take part in the Linux Foundation mentorship in one of two ways. So individuals can register themselves to say that they will be a mentee, and you publish the skills that you have, and then people that are interested in being mentored will then approach you and say, hey, can you be my mentor? The second way that you can get involved is actual projects can publish actual CNCF projects or open source projects can publish projects, specific tasks that they want mentees to work on, and they invite applications. And this is normally for a period of time, a 3-month period, and they call them terms. So at the moment we're going through the spring term. So I'm actually a mentor for 2 mentees. One's working on the GCP provider, Fong, and he's doing some great work with OpenTelemetry and adding that to the provider. And also on the AWS provider, we're working with Avartha, and he is basically trying to get rid of one of the biggest pain points in the AWS provider, which is basically moving away from CloudFormation. But more generally, it's an excellent way for people to just experienced people to share their experience and their knowledge with people that are just starting out in their careers and helping to build the next generation of engineers. So I would encourage everyone to either get involved, whether it's on a personal or a project basis.
So is it a good way? Is it a good way to find a job in your first place, or once you're in a job, maybe you do this as part of your job, and how does it fit into a new person's career path?
So that's an interesting question. So it gives you, so a lot of the time we work with students as being mentored via the program. And they have a specific deliverable that is delivered by the end of the project. So they have something concrete that they can point to. And actually, a number of them, the mentees, have previously had job offers subsequently. So they're demonstrating, working with open source, making changes, and their skills as a software engineer.
That makes so much sense. That's super cool, especially if you already have some skills. As a way to get a job or to improve your job. So do you want to talk specifically about cluster API opportunities in that space?
So the spring term is currently coming towards the end, at the end of this month. So we've got about 3 weeks left of the spring term. So then the projects are invited to submit their ideas for the summer term, which will start a bit later. I forget the actual dates. So potentially we will be submitting some more project ideas that people can apply to as well. It's just a bit too early at the moment to say these providers will have projects. But
did I hear you say the students submit ideas?
No, the projects. So,
okay.
So the open source projects and individuals. But specifically this, it's the CNCF projects.
Cool. Make myself bigger, and then we have some comments in the chat that I want to highlight. So to answer a question, Bucky Buck's using scripting using Terraform, AWS SDK, and Helm templates to provision clusters.
Nice.
EKS Cuddle create cluster.
Yes.
Definitely need to improve on that and learn some tools and use some tools. So you've come to the right place, Carlos. Thanks for coming. And then Kurmaju has a question. In this show, are we talking about differences between different platforms like Crossplane, Terraform, and Managed Cloud Kubernetes?
Not specifically. So we'll probably be talking specifically about cluster API. So obviously you can provision clusters using Crossplane or Terraform. So they are alternatives, and there's some pros and cons between whether to use one or the other. And the managed cloud Kubernetes, so the managed services like EKS and AKS. So that is something that Cluster API covers to a greater or lesser extent, depending on which cloud you're talking about. And there's lots of work going on in Cluster API at the moment around managed Kubernetes. But specifically, we could cover, if we had time at the end, some of the differences and why you might want to use one or the other, or combine the two. So it doesn't have to be I'm going to use Cluster API or Crossplane. There might be scenarios where you could use both together.
Cool. I love that about the CNCF landscape, that so many things are just complementary. So to begin this conversation, I have a question, and then I'll let you more or less guide the conversation from there. But as a relatively new learner, I really like to understand what problem Cluster API is solving. Like, what was the world like before Cluster API existed?
Yeah, and that is actually the reason why Cluster API was originally started. So it was built on that premise that cluster lifecycle management is difficult, or was difficult, and this was especially the case. Depending, if you try to operate across clouds, different infrastructure environments, and trying to have like this consistent operational model when you're talking about cluster lifecycle management, it's been traditionally hard. There hasn't been a common way, or common pattern, or common operational model to provision clusters, and so that's why Cluster API was started. So, for example, go for it.
Oh, so like, can you give me an example of what cluster lifecycle management, a difficult cluster, like looks and feels like? What you might try to do that you had to do manually, or
well, I guess it was
something.
Yeah, I guess it was. So the tooling, I guess, has matured, and our understanding of what people want, when they're provisioning clusters, has matured, since Kubernetes was born. But one of the main gripes was, if I wanted to provision a cluster in, let's say, AWS, I had to use, let's say, COPS. If I wanted to provision a cluster in another infrastructure environment, I had to use some other tool, and there was. Which was fine if you only ever operated in one sort of target infrastructure. But then as soon as people start talking about cross-cloud, you start to have two different ways to operate these clusters, which is, it's problematic if you're an operations team. And then just to throw another curveball in there is, if you're using something like GitOps, a lot of these, the previous provisioning mechanisms were imperative. So it would run all of the, you would invoke it once, it would run all of the steps, and it would provision your cluster. It didn't lend itself well to GitOps. And it's sort of, I guess the adoption of GitOps has sort of gone in parallel to the adoption of CAPI, because they are natural fits. I'm a big GitOps fan, so I'm slightly biased.
Did you? You just said something CAPI. I don't know what CAPI is.
Oh, sorry. Yeah, that's a very important thing. So CAPI is the acronym for Cluster API. So CA.
Oh, okay.
Yeah.
This has happened in the last 3 episodes where my browser has disconnected from my camera and I've had to restart my whole setup. So I'm going to do that now. I wish I knew how to troubleshoot this or how to solve it. I thought I had it figured out, but I clearly did not. I'm going to finish, even though you can't see me, I'm going to finish writing, what my thought on the board. So what I have written, it's going to be, this is like charades or something. So what I have written is, before Cluster API, it was relied on scripting. People relied on scripting, which was bad for GitOps, which made GitOps impossible. Is that correct?
Well, scripting and other tools. I know, like tools like COPS, and if you're going back, tools like Kubernetes, which were originally tailored to like one target infrastructure environment. Some of the tools have obviously evolved over time and support other target infrastructure environments, but I guess the key thing is a lot of them weren't declarative either.
Yeah, great. So relied on scripting is kind of another way of saying not declarative. I'm going to troubleshoot this now. We have some great Nick, the first one's here. Hi, Nick. Thank you for coming. So maybe you can answer Goramaju's questions a little more, or we have some great folks in chat who can ask questions right now while I restart. And or you're just welcome to riff about whatever you feel passionate about. Maybe tell us more about your KubeCon talk. But I'm going to disappear here for just a moment.
Cool. Yeah, maybe we can touch on the managed cloud. Managed Kubernetes services in Cluster API temporarily, because traditionally, when Cluster API started, it didn't have support for the managed Kubernetes services, and in fact, probably the only managed Kubernetes service at that time when Cluster API started was GKE. But as time has gone on, obviously there's more managed Kubernetes services. So Cluster API itself has had to adapt and evolve to try and fit in the concept of managed Kubernetes service into its API. And more recently, there's been a lot of work going into this to make that story a lot better. And it's difficult because this involves changing the APIs over time, and then you have to have guarantees on those APIs. So that's an ongoing work. But currently, as far as managed Kubernetes go, there is good support for AKS, good support for EKS, and there is experimental support for GKE. GKE was only released a couple of months ago. And it's still not feature complete. So that's another good area if people are interested in contributing to Cluster API. Continuing the support and adding the features to GKE in the GCP provider would be a great place to start, because that provider has been historically unloved for quite some time, but it is getting more love these days. So hopefully that answers that question. And I guess we could also cover the other parts of that question, which is crossplane and Terraform. So yeah, you can accomplish the same things. I think one of the main differences between Cluster API and crossplane and Terraform is Cluster API is opinionated. It has opinions on what the underlying infrastructure should look like for when creating a cluster, whereas crossplane and Terraform, you have a bit more freedom, and so that means you can do more. So just reading Carlos's comment from LinkedIn. The industry has needed something similar. So I think what the industry has needed is a common operational model around cluster provisioning and the life cycle of those clusters, and that has traditionally been hard, and so it definitely has needed something like that. And I guess that's from an end user perspective, but also there is the flip side where if you're building a product where provisioning clusters is core to that product. Having a common way to interact with and create clusters really helps as well. And there's some aspects of Cluster API that make that really interesting to companies that are building products and services. So, for example, Tanzu, Rancher, and D2IQ, that's what makes CAPI interesting to companies like that. So just checking. And so Carlos also mentioned about EKS Cuttle. So that's an interesting one as well. So EKS Cuttle was the first open source project I contributed to. So in the early days when Ilya started it, that was how I really got into open source work. I was the first non-Weaveworks contributor to it. And I love EKS Cuttle. Hey!
Woo! Yay! I could hear some of that. I was also quite distracted and a little stressed. But that was fantastic. Thank you so much for keeping the show interesting while I was gone. So we have Nick the First One is here. Hi, Nick the First One. So glad you're coming. Nick the First One, he was one of the very first people to like ever come to any Enlightening episode ever. So and his handle was already Nick the First One. That's unrelated. Um, and we have Vincius here from Brazil. Thank you so much for coming. And I was able to put Carlos's, like from my secret ghost place, I was able to put Carlos's question onto your screen while you were talking. Uh, all right. So to recap the short little bit we've gone over, you're painting a picture for us about what the world was like before Cluster API. So cluster lifecycle management was super difficult, and then it also was imperative. So it relied on scripting or a series of steps, and that was bad for GitOps instead of like just defining the final state of what you want a cluster to look like and then relying on another tool to implement that state. So that's the world we used to live in, and then here we are. Cluster API came onto the scene. So, do you want to maybe tell us what is Cluster API? Give us a succinct definition.
Yeah. So I guess if I had to describe Cluster API, so it's a project that brings Kubernetes style APIs and patterns that will then automate the life cycle or the cluster life cycle of just the cluster life cycle, and you can do this across many target infrastructures. So there's the two key points there is having an API definition that anyone that's used to working with Kubernetes is used to. So
okay,
you have your declaration
that uses custom Kubernetes resources.
Exactly. Yeah, this will be on custom resource definitions. There are a bunch of them.
Thousands. Kubernetes custom resource definitions. Okay. And controllers too, really, right?
Yeah, exactly.
Okay. It uses that to do what?
So ultimately, the goal is to manage the life cycle of a cluster from creation through to operation to death. To put it bluntly.
I hadn't anthropomorphized my clusters yet, but now I have. Now I feel
yes.
sad for the passing of clusters. And we can assume this is all Kubernetes based. There's no so it manages the lifecycle of Kubernetes clusters. Is that correct?
Exactly. Yeah. It's only for Kubernetes clusters.
And Cluster API is a sub-project of Kubernetes. Is that true?
It is. So it's in Kubernetes SIGs, and it falls under SIG cluster lifecycle. So yeah, it's a sub-project.
What does that mean practically?
That's a good question. If you talk to some people, practically it causes them a lot of pain when they're trying to arrange conferences and work out if someone's a maintainer of a project. And but I'm being a bit facetious there. but it basically just falls all under the umbrella of the Kubernetes project. So you know it's all. That's the best way to describe this. So Kubernetes is big. It's a big project. It has lots of different aspects to it.
Yes.
So, but there's obviously the core of Kubernetes, and then there's all these projects that sit around it. And when I say it's a sub project, I guess there is the practical aspects, which is it sits under the same governance, but then also under the same GitHub organizations. And so then you can take advantage of all sorts of things if it sits under the same org. Things like testing, having the test infrastructure to run all your internal tests and all the interactions with contributors on the GitHub issues and pull requests and things like that.
Is that a choice? Like when somebody decided to make Cluster API, is it a choice you make when you want to make a Kubernetes tool, do you think to yourself, do I want it to be a Kubernetes sub project, or do I want it to be its own CNCF project, or
Good
is it just kind
question.
of organically happen? Yeah.
Yeah, it's good question. I don't know. Is the answer? Some people obviously make the conscious choice. They start a project and they put it under the CNCF as a separate project to Kubernetes. So then you have to go through the correct process to get it accepted into Sandbox and go up the graduation until it's graduated. So I guess if you do it as part of Kubernetes is already in CNCF, so you're sort of fall under its umbrella, which means but then you also have to fall under the umbrella of all the governance that the CNCF expects of the Kubernetes project. So, and then some people start projects and then donate them as well. So they start projects and go, hey, this is in my repo, I'm going to donate it to the CNCF or Kubernetes. And then there's whole processes around that as well.
Okay. It's all a bit of a mess, but an organized mess. We have lots of questions in chat right now, so let's talk about those before we move on.
Yep.
So Cluster API is an automation tool to create and customize a Kubernetes environment. The word environment means different things, right? So I can, sometimes I hear about a development environment, and that not only includes the actual machines and the installation of Kubernetes that's running on the machines, but it can also mean all the extra tooling that's needed for a specific application. And so this, if I understand correctly, Cluster API is only concerned with the actual machines, the physical or virtual machines that form the cluster.
Yeah.
And maybe the Kubernetes version too.
Yeah, so it cares about the infrastructure that is required for your cluster. I like to describe it as the base infrastructure, because a lot of times before you even get to creating a cluster, you need some sort of base infrastructure.
And tell me again what you mean by base infrastructure.
So this is anything you need to set up in a particular target environment. So when I say target environment, I mean something like AWS or perhaps in a data center. So, but if I take AWS as a good example, if I want to create a Kubernetes cluster in AWS, I'm going to have to do some stuff around creating a VPC and some networking stuff. And maybe some security groups and stuff like that, which is all these infrastructure resources that need to be created before I can even think about doing anything with Kubernetes.
Okay. So Cluster API cares about the base infrastructure, and what else?
Then it cares about the infrastructure required for Kubernetes. So what I mean by that is things like virtual machines or physical machines. So it needs to know how to create those or provision those.
Okay.
But this, I guess, these two things still fall under the umbrella of infrastructure in the Cluster API world.
Okay.
And then, so we've got our infrastructure. We actually have to we need to know how to actually create a Kubernetes cluster. So how do I bootstrap Kubernetes onto a machine? So it cares about that bootstrapping process
Is that, can I say how to install Kubernetes? Does that mean the same thing as bootstrap?
Yeah, why not? Yeah.
Okay.
Because that's essentially what you're doing.
Okay. Cool.
So then, so we've got our base infrastructure, our machines, we've bootstrapped Kubernetes onto those machines. So now we have a cluster. So this is then when you get into the operations, operating that cluster, a newly created cluster. So Cluster API has aspects of what I would say like day two operations. So, for example, you may want to upgrade the Kubernetes version of your cluster. So that ongoing operations of that cluster.
So can I maybe by saying it cares about the current state of the cluster?
Yeah.
Does that capture what you're
Yeah.
describing? Cool. Great. This was a very great question and a very useful exercise. So thank you. Um, and I'm going to jump to the next question, which is by Carlos. Carlos is curious to know if there are any efforts to help customers with workload migration, or would that fall outside of the scope?
So when we talk about, hey, you have a cluster that is provisioned by some other means that's running workloads, and then you create a new cluster via cluster API, and then I'm assuming we're talking about migrating those workloads across. So that would fall outside of cluster API. As would sort of a related topic that we often hear, which is I already have a cluster created using tool X or manually, and I want to adopt that into cluster API. Again, that currently falls outside of cluster API because that's a difficult topic. But yeah, migration of workloads is not something that is covered.
All right. Fuel Schnabel says migration and upgrades always fall outside. Kormashu has another question. So what distributions of Kubernetes does Cluster API support? So Rancher, OpenShift, VMware Tanzu, Managed Kubernetes.
So there's quite so this is all dependent on I guess there's two aspects to this question. So there is, I'm thinking, well, three probably actually. So there is the target environments. So where can I actually create my clusters? So that's one aspect. Then there is the actual Kubernetes distro. So what flavor of Kubernetes am I going to create in that target infrastructure? And then also based on that list, then there's probably, what open source and commercial tools that use Cluster API can I use to create those? So I'll start with the easy one. So actually the target environments, so it covers all the major clouds. There's providers for things like Tinkerbell, Oracle Cloud as well. So it's got you covered there. And actually I can, there's a list of providers. So that's from the target infrastructure environments that supported.
So the target Cluster API supports all major cloud providers.
Yep.
Okay.
And bare metal type scenarios via things like Tinkerbell and Metal Cubed. So it's quite a list of providers and target infrastructure environments.
Okay, with those major providers. And so all major cloud providers, all major bare metal tool providers.
Yeah, and
they're not called providers. Yeah.
Yeah, yeah, can do. Don't see why not.
We can invent the rules here. It's our land. Okay. All right.
Yeah, and I think then there's the flavor of Kubernetes that goes on top of those. So, so the default default flavor of Kubernetes is a Kubernetes cluster bootstrapped or created by kubeadm, and another Kubernetes project. So that's I guess standard Kubernetes. But then there are other flavors of Kubernetes that you can create via various providers. So there is a K3S provider. Perhaps you want to use K3S or RKE2. And there is even another flavor, which is EKSD. So EKS distro as well is another flavor. So there's lots of options here.
Okay. Mm-hmm.
And then I think then the other aspect is what other tooling is using Cluster API. So yeah, it is used via in Tanzu. It is used in D2IQ. It is used currently in Rancher as well, and will be used more in Rancher. But it's also used in things like EKS Anywhere that AWS created for provisioning EKS clusters outside of AWS Cloud.
So, so for tooling, I got Tanzu and what else?
So basically the major container orchestrators. So Tanzu, Rancher, D2IQ, OpenShift uses the machine API. So and then EKS
Okay.
anyway.
Cool. Excellent. Another great question from Kormaju. Thank you so much. Here we have another question. Fuel Snobble thinks they'll get kicked out for considering this, but how many tools are there surrounding Kubernetes? What does the core do, and how could we do it without these tools before? That's a very, very, very large question. The CNCF landscape encompasses the CNCF landscape. Most of those tools work on with Kubernetes, but not 100% of them. Some of them are just cloud tools, and there are something like 150 CNCF projects. And then on top of those CNCF projects, we have the Kubernetes sub projects, which we were just talking about. Do you have an idea of like how many Kubernetes sub project tools there are?
No, I wouldn't even want to estimate. Lots.
Lots. So
Yeah.
I know that Victor and I have the You Choose show going where we're trying to touch every single CNCF project, and Victor's been confidently saying there are over 200 projects that we'll end up touching as part of that show. And so so that answers that part of the question. And then what does the core do? So I'm not sure. By the core, do you mean just like the vanilla Kubernetes, like the exact Kubernetes project, or do you mean Kubernetes plus Kubernetes sub projects? What do you think would better define the core, Rich?
Or I have another take, or another option, which was what does core Cappy do?
Yeah, let's bring it back to what's.
So I don't know. It could be any of those three options.
Okay. So what does the core at Cluster API do? Might be the question. So let us know what your question is, and then how do we do it without these tools before? So some tools bring completely new functionality, like bringing in events, like you couldn't before events existed, like event type tooling existed in Kubernetes, you just couldn't do events in Kubernetes. And then other tools are taking something that Kubernetes could already do and then making it easier and more accessible, and maybe abstracting away complexity for a developer persona. So in some cases we couldn't, and in some cases it's easier, is the short answer, I think, to that. Yep. Do you agree with everything I just said?
Yeah.
Cool.
Yeah.
Excellent. Y'all have been asking wonderful questions today. Thank you. So I have a guess, Rich, that maybe you're excited to talk about what does core Cappy do?
Yeah. Well, I can do. Yes.
Wait, what does core Cappy mean before you tell us what it can do? What is it?
Yeah, so I don't know if it's the official term, core Cappy. It's a term I use. So Cluster API has two parts. It has what I call core Cappy, which if you boil it down, is the core API definitions and their controllers. And the reason why I call it core is because it's the central orchestrator of everything that happens in the provisioning and the lifecycle of the Kubernetes clusters that get created via Cappy. So it's the thing that defines all of the contracts. So we haven't touched on this yet, but there is contracts that are defined that enable this. So then core Cappy.
Hold on, you're getting a little bit ahead of me. Core Cappy consists of you said the APIs, but another way to say that is these custom resources you were talking about.
Yes, exactly. Yeah.
And so custom resources, and then which custom resources specifically again, please?
There's a few. So the main one, and I guess the root of everything, it's called cluster. Funnily enough, and that's the cluster CRD.
So the core Cappy just makes up the most essential custom resources in Cluster API. Is that what you're saying?
Yeah, and it has the,
Okay.
I guess, so these custom resources represent the cluster as a whole,
Okay.
and specific parts of the cluster. So, for example, there will be, if I say the cluster as a whole, that will be the cluster custom resource. But when we talk about specific parts of a cluster, there is custom resources for machines and for control planes.
So, and so those are three different resources that you just said.
Yep.
And okay. So,
There,
I'm just thinking about how to organize this information. So, a cluster custom resource. Do you want to like define what that custom resource does? Maybe we'll just move across the bottom here and.
yeah, we can do. Yeah. So the cluster
Okay.
resource is it logically represents the cluster as a whole. So if you're creating a cluster, the first thing you have to do is create one of these, and that's saying, hey, I want to create a new workload or child cluster, and it contains some general configuration information about the cluster that isn't specific to any target infrastructure environment. So to give an example, say it might contain what you want the pod CIDR block to be for that new cluster, but that is general. It's that applies to any cluster created anywhere. There's nothing infrastructure specific about that at this time.
CIDR stands for inter-domain routing. Shoot.
You test me now.
I try to have an acronym free show, or at least explain every acronym we use. Inter-domain routing. I'm sure about the IDR. That's all right.
Yeah, I can furiously Google.
It's all right. Maybe someone in chat will tell us, and if not, that's okay.
Yeah.
We can look. Oh, now you need to know. I respect it.
Classless
Classless.
inter-domain.
Classless.
Yeah.
Oh, I thought of it right when you said it. Okay, cool. Classless inter-domain routing. So a pod CIDR block.
Yeah.
Cool.
But the main thing here is that's agnostic to any infrastructure. It's general for the cluster. And the thing about the cluster here, it then contains references to other custom resources, and those other custom resources are provided by specific types of providers, and you must supply. Currently, it has two specific resources. So it has a reference to an infrastructure provider. So you're saying, I want to create this cluster in this target infrastructure, and so there is this reference to that infrastructure specific representation of a cluster. So what you often see in CAPI is there's pairings. So we have the CAPI, core CAPI cluster here, and that will reference a infrastructure provider's representation of a cluster. And to give you a concrete example, cluster here will reference AWS cluster, and the AWS cluster custom resource is supplied by the AWS infrastructure provider.
Okay.
And the reason why this is done is when you're creating a cluster, there's always going to be infrastructure specific configuration that is needed.
Yes.
And this is where the concept of the providers come in. So core CAPI doesn't provide those CRDs. It's supplied by a cluster API provider, of which there's different types of cluster API providers. Main one being the infrastructure provider.
Provided by provider.
Yeah. Mouthful.
We have some comments. Carlos is on the way out. Hopefully we caught you. We'll have to jump. A great presentation. Hope to participate more. Thank you so much for coming, Carlos. It was lovely to have you here. And then Fuel Snubble was clarifying that they meant Kubernetes without all the sub tools or the sub projects. So
Yeah,
what is core Kubernetes? Yeah.
so that is just that's often referred to as if you go to GitHub, the Kubernetes repo in the Kubernetes org, KK. So that is the core of Kubernetes. That is Kubernetes, and that's, I guess, the main thing.
And so Kubernetes is it's basically software that runs software, and that can happen without all the bells and whistles. So there's some Kubernetes, like we're talking about a lot of custom resources, like basically all the Enlightning shows lately have to do with custom resources.
Yeah.
So anything that's just a resource and not a custom resource is a Kubernetes resource. And so technically you could run your software in Kubernetes with the core Kubernetes resources, and you could still have a lot of the benefits like scalability or cost optimization or resiliency, but it's just a lot more tedious and harder to come by, and might involve things like relying on scripts and imperative ways of operating the cluster.
Yeah, and especially for, I guess, more complex type applications, and that's obviously where CRDs and operators come in, which is basically what Cluster API is. It's just a Kubernetes operator. It has CRDs and controllers that reconcile them, which is like a lot of, I guess, the things that bring extra functionality on top of Kubernetes.
I just recently I've heard the word operator in my periphery for a long time now, and I just recently drilled someone who is an operator expert, like what is an operator? And best I could tell, what an operator is a CR, like a custom resource wrapped in with a controller, like all packaged together as an operator, as opposed to talking about the CRDs and the custom resources as separate things.
Yeah, some people talk about, I guess, controllers and operators as one in the same. I guess it depends on, I guess, your viewpoint. I guess operators, for me, this is my own personal view. I don't, not sure if it's right or people agree, but I see that operators are a collection of controllers. And those, obviously, and what you described then is I guess the controller pattern, which is you have an API or CRD, and you have a controller that reconciles that, and then you can have multiple ones of these into an operator. And someone described it to me as it's essentially doing what you would do as a human. You would do these steps to accomplish a specific operational task, and normally it's fairly involved, and you'd have to maybe configure this, configure that, and do this. So it's just codifying all of that. That's the way I like to think of it.
Yeah, I think that's very helpful for my mental model. Thank you. So Fuel Sample is saying, so Kubernetes is like an operating system. I've heard Kubernetes described that way before, like an operating system that runs across several machines at the same time. What do you think about that description?
Yeah, I've heard that before. And it's similar, but a high level of abstraction, isn't it? But yeah, I agree. It provides lots of different services that you can take advantage of. So yeah, why not? Operating system for containers.
Yeah, I love it. So Cormaggio has another question. Cluster API comes under vCluster or Kubernetes tools? I guess I don't understand the question. Do you understand it, right?
So vCluster is separate. So Cluster API comes under Kubernetes 6, is in the org. vCluster is something slightly, it's a different project.
And Cluster API is Kubernetes specific.
Yes. Yeah. So the only thing you can provision with Cluster API is another Kubernetes cluster.
Yeah. Gotcha. Okay. So we're talking about core CAPI, which is custom resources. And we've talked about the cluster custom resource, which represents the cluster as a whole. It itself is infrastructure agnostic, but it is going to reference other infrastructure specific CRs that are provided by the cloud provider. Yeah,
by the CAPI provider. Yeah. and there's different provider types, but yeah, the biggest one is the infrastructure provider. As the name suggests, the role of an infrastructure provider is to provision infrastructure.
So infrastructure provider is a custom resource in the core CAPI, right?
It's what CAPI refers to it as a provider type, and each provider type has specifics. Each provider type provides custom resources, and those custom resources have to adhere to a certain contract depending on the provider type. And this is how Cluster API and providers can talk to each other. And this is sort of, I guess, it's a core point to the extensibility of Cluster API. If that makes sense.
So an infrastructure provider is not part of core CAPI. We're talking now about like something that a specific provider would provide to be able to integrate with core CAPI.
Yes.
Okay. So okay. And it's not, it's a group of custom resources. It itself is not a custom resource. Is it packaged? Like, does it package the group of custom resources so you can import like the provider and then have access to all the provider's resources, or are you choosing?
Yeah. So every provider's packaged separately. So you can when you we haven't covered this term yet either. So you can choose which providers to use or not when you essentially install Cluster API, and they are Cluster API providers on the whole are completely separate projects. So I say on the whole because there are other scenarios, but they're normally separate projects, separate repos, separate release cycles. But the main point is the providers own their own custom resource definitions, with the caveat that the custom resource definitions have to adhere to a contract. When I mean like adhere to a contract, they must have certain fields within the custom resource definition.
So they're made up of CAPI compliant CRDs.
Yeah.
A provider is made up of CAPI compliant CRDs.
Yeah.
Is that accurate?
Yeah. And the compliance is the contract. Yeah, it is to a contract that is published by core CAPI.
Okay. A core CAPI contract. Say that 3 times fast.
Yeah.
Okay.
And the other question that normally comes up here is, well, can you point me to the contract? And it's like, well, actually, the contract is written down in documentation. There is not a there's a contract definition that you can run against your CRDs to check it.
Is that a good intern project?
It would actually be. And funny enough, the subject of contract conformance or conformance testing has come up quite a lot recently, and it actually came up at the Contributor Summit in Amsterdam. So cool. Yeah, that would be good. That's a great idea for one, actually.
So we have cluster API provider. So we just talked about an infrastructure provider, or right? Okay, and you're going to tell us about more providers. Yeah,
so traditionally there's been 3 provider types, so we'll cover the main ones. Okay. So the infrastructure provider we've covered, and examples of this would be the AWS or the GCP provider.
Okay.
So the next provider type is the Bootstrap provider, and the Bootstrap provider has one role really, and that it's split into 2 parts. It has one role, but it's split into that is split into 2 parts. So the Bootstrap provider's role is basically to generate the instructions that are needed to create a Kubernetes cluster or join a node to a cluster. So essentially, this will mean creating the command line for kubeadm, so kubeadm init for the first machine, and that will, initialize a Kubernetes cluster. Or if it's a second machine, the Bootstrap provider will go, oh, okay, I need to join and I needed slightly different commands, so kubeadm join. And this is where you get into being able to support different flavors of Kubernetes. But that's the role of the Bootstrap provider.
So, just semantics, but is this a custom resource or is this?
Yeah. So every provider type will have custom resource definitions and a controller that goes with it.
And do all of them also have that CAPI contract?
Yep.
Okay. So true of all provider types. And all of the providers are separate projects. Is that true too?
Yep. No, sorry, I spoke too soon. So in most cases, yes. So most of the providers are separate projects. The exception to that is the within the main cluster API repo, it also contains providers for kubeadm. So these are like the original Bootstrap and control plane providers, and they live in the same repo as core CAPI. So so in most instances, they are separate projects.
Okay. So, all right. And so now I have another question. So if these two things I wrote about infrastructure providers are true of all provider types, then what an infrastructure provider, does it make custom resources for like all the little choices you make within setting up an AWS cluster? Does it give you custom resources for that? So now you have a custom resource for like your, what do we talk about? VPC, for your networking, for your security groups? So
yeah, that's a good question. So it's up to the providers how they structure their custom resources. But the main thing is what you often have is this pairing. So in core CAPI, we have the cluster custom resource type, and this has to reference a single resource type for the infrastructure provider, and so that is generally called the infrastructure cluster, and that will have a single CRD. Normally, it doesn't have to, but normally it does. And as you say, that will then contain all of the configuration, infrastructure specific configuration for example, for that base infrastructure that we talked about earlier.
So you have a cluster that represents the cluster as a whole, and then that has general configuration and is infrastructure agnostic, but then you reference other CRs, and you do that by referencing an infrastructure provider.
Yes. Yeah.
Which isn't in itself a CR, but it's made up of CRs. Then we're not going to get up into the CRs that it's made up of because this is complicated enough as it is.
Yeah.
And that's as much as we need to.
Yeah, just think of it.
We need to understand right now.
Yeah, probably to in most instances it's a one-to-one, so there'll be one CR for the infrastructure representation of a cluster. So it's probably
okay.
And when we start to talk about machines, it's the same thing. There's this pairing. So there's a core custom resource definition and a infrastructure specific custom resource definition.
So one-to-one provider to custom resource relationship. Great. And we have another question from Cormaggio. How do you manage certificates with Cluster API?
So generally, Cert Manager is installed into the same cluster as Cluster API. So that does a lot of the certificate stuff. So then you may want to do an infrastructure provider, for example, may want to do some other stuff with certificates that is specific to that infrastructure environment. I'm trying to think of a case where that is done.
I know from working through Kubernetes the hard way that to set up a cluster the hard way, you do have to set up certificates between every single node in the cluster so they can communicate with each other. So if you can't install Cert Manager at that point? So
So there's so KubeADM does a lot of this. So KubeADM does
okay.
a lot of that heavy lifting and automates it. And there is things like a token. So you can't just join a node without that token to join. So that's how that's handled as well.
Okay. And then Cert Manager or any would be used for managing certificates after that.
And Cert Manager, I guess to be clear, is generally used for things like certificates on the emission webhooks and things like that. So we all have those certificates.
Yeah. And we have, Cormaju, you might have been there. We have a certificate, a Cert Manager Enlightning episode. So it seems like the de facto way to manage certificates in Kubernetes. I haven't really heard of another, not one that's not a product. Cool. So we have a third provider type.
Yes.
Did you say everything did we capture everything you want to say about a Bootstrap provider?
So the main thing is it's obviously coming up with the instructions that need to be run on a machine to bootstrap Kubernetes or join a machine to an existing cluster. There is one other part that it does as well, which is somehow these commands have to be executed on that machine. So as well as coming up with the commands, it also formats the commands in a way that they can be executed on a machine on first boot. So what I really mean here is formatting the commands as Cloud Init or Ignition.
Okay. So it really depends. So formats the commands so it can be executed in a way that whatever tool you're using to set up your cluster wants to hear the commands.
Yeah.
Okay.
So it has a mixed role. So there is some talk about splitting the roles. So formatting commands to be run is a separate task to the actual commands that need to be run. So there is talk about trying to split these two things up.
I have questions. I have two questions. One is, I'm beating a dead horse here, but what's the point of having the word providers if a provider and a CR is a one-to-one relationship?
So it is a one-to-one, but along with the custom resources, the provider also has a controller. So that controller then does the infrastructure specific stuff. So in the case of an infrastructure provider, it will do all of the things like creating the VPCs, setting up the network, creating the internet gateway in the case of AWS. So it does all of the, as well as holding the configuration, it does all of the reconciliation. So all of the interaction with the infrastructure environment.
A provider is a CRD plus a controller.
Yeah. So the idea is really that you say, hey, I want this cluster in Cappy, and then what the infrastructure provider will do, it will go and do its thing. It will create the infrastructure, and then it sets a status, and that sort of signals back to Cappy that it can then move on with the provisioning. So there is this well-defined life cycle of, I guess it's like a dance. I call it a dance. So this controller does something, and then this controller does something, and it's backwards and forwards, like down until you have your cluster.
Love it. I like that a lot. And then, so my second question is about whatever tool sets up the cluster. Can we talk briefly about what types of tools set up? We've been saying KubeADM. I probably should have just slowed down enough to be like, hey, it's just a tool that sets up the cluster. But it's like when I studied, I didn't get it. I didn't ever take the test, but I studied for the KC. I forget one of those Kubernetes certificates. I got too busy, but and so I learned about KubeADM from that. But it's just a tool like that sets up a vanilla Kubernetes cluster.
Yeah, exactly.
Do providers tend to have their own tool, or do they tend to rely on KubeADM?
So that's an interesting one. Yeah, so traditionally, all of the infrastructure providers would have just relied on the KubeADM bootstrap provider. because that was one
Okay.
that was supplied by Core Capi, and it was agnostic. It would just run on a virtual machine in AWS, and it would also run on a bare metal machine. So, and it was the core, I guess, the standard Kubernetes way of provisioning or bootstrapping a cluster. I say kubeadm. Some people say kubeadmin. But yeah, so there is an assumption, I guess, that those tools are available on the machine that is being
Okay. And then
turned
what
into.
are other tools then besides kubeadm?
So you could use something like K3s. So if you wanted like a super
Okay.
lightweight Kubernetes distro, there's K3s.
Okay.
And then you have a variation of that, RKE2, which is K3s but hardened.
Say those words, those letters, and numbers
K3s.
again.
Yeah, K3s.
Okay. Oh, I got that one.
RKE2.
RKE2. It's like it has the same R2D2 ring to it.
It does, yeah.
RKE2. Okay. Okay. Cool.
But yeah, I guess. But if there was another flavor of Kubernetes, maybe someone came up with, I don't know, a super lightweight Kubernetes distro with everything stripped out and a different backend.
Isn't there a K0s? Yeah, I'm pretty sure
there's
K0s in the world.
Yeah. So that could be used as well. So as long as there's binary that could be invoked. Yeah, mostly. This is where it gets into a gray area.
And didn't you say KOps? Is that a tool that sets up clusters?
Yeah, Kops or KOps. Yeah, it's been around a long time.
Okay, I'll write Kops in there, and
that predates Cluster API by a long way.
Oh, when is Cluster API born?
Funny enough, we were having this discussion. I was trying to find out the exact date prior to this. So the first release was in 2018, I believe. Let me just check the date. In June 2018. Obviously, the project started before then. There is some confusion as to exactly when before then it started, but best guess is late 2017 actually coding started, or early 2018.
Cool. All right, so we have one more provider to talk about.
Yes, and that's the control plane provider. And as the name suggests, this is used to control the creation and life cycle of the Kubernetes control plane specifically.
Okay.
Yeah, this is where it does get more interesting. So we've already got
very interesting, Rich.
Yeah, so we've already got the cluster that can reference an infrastructure custom resource, infrastructure cluster custom resource. The cluster also references a control plane custom resource, and that control plane. So that control, to give an example of the control plane, that would be kubeadm control plane. So this control plane is provisioned via kubeadm, and to be able to actually do that, we have to create a control plane in Kubernetes. We have to create the machines that are going to be used for the control plane nodes, and we have to bootstrap Kubernetes onto those. So, the control plane itself then relies on the help of an infrastructure provider and a bootstrap provider.
Yeah. So it's concerned with the control plane and lifecycle of the Kubernetes version. The Kubernetes. Help me with my words.
The Kubernetes control plane. So the Kubernetes control plane nodes. So the things that have like the Kubernetes scheduler and the API server on, and not the worker nodes.
Not the worker. Okay, got it. That makes sense. So these what it sounds like what you just said is they're not linear, but I don't really understand how they can rely on like something has to be created before something else. So in my mind, so it sounds like an infrastructure provider would create all of the infrastructure needed, and then a bootstrap provider would do the work of installing Kubernetes onto that infrastructure. And then the control plane provider would be like, how is your particular instance of Kubernetes configured? Like, do you have more than one scheduler? Which one's the leader? Like, where's your etcd cluster? Like, those kinds of considerations would be a part of the control plane provider.
Yeah, pretty much. And I guess with the caveat that the control plane provider can also rely on an infrastructure provider and a bootstrap provider. So there's this hierarchy. Best way to think of it is, I think if you go back to what the tasks that have to happen. So when we create a cluster, we need that base infrastructure. Basically create everything in the target environment that isn't related to a machine. So if your target environment has a concept of projects or a private network, so create all of those things. Then you get onto, once I have that base infrastructure, I need to then create the control plane. That's the first thing that actually gets created from a Kubernetes point of view. And actually to create a control plane, I also need to provision infrastructure because I need that node to run.
Now you need the idea of a machine. Yeah.
So this is where the concepts of machines come in, and like the cluster, they come in pairs.
Okay. I'm very interested in actually pursuing this linear path of what's happening behind the scenes.
Okay.
But it's fascinating to me, and it's also how my brain works. But then, like, I know I know there were other core custom resources that you maybe wanted to get to, and I'm aware that I'm kind of taking up a lot of space. So I guess I want to, before check in with you and ask you, like, what's a better path? Also, Koromaju has another question that I'm sure is great. What's a better path, doing this linear thing that I want to do, or getting into custom resources? And there's probably time and board space for both.
I think probably as you do the timeline or the linear thing, it will tease out the other custom resources as we go along.
Okay, cool. Yeah. I love it. And then let's get to Kormaju's question. How do you configure and manage storage in sidecar containers?
Interesting. So sidecar containers, Cappy doesn't care about. That's normally for workloads.
So it's probably like just like with certificates where you pull in another Kubernetes tool to do that. For sidecar containers, you would probably install Istio or some other service mesh. So you would just use a whole separate project for that.
And that probably is a good point is. Cluster API doesn't care necessarily about the workloads that are on top of running within the cluster it's created. Again, that's not entirely true, but it generally doesn't care. So if Cluster API provisions a cluster and then you want to install workloads on there that have sidecars that are injected, you go for it. That's just a Kubernetes cluster. You can do whatever you want with it.
And then now, storage might be something that's could be considered part of infrastructure or something you consume from your cloud provider and connect to it. So is storage fall under the umbrella of CAPI?
To a certain extent, yes. So obviously storage is needed when you're creating potentially, it's not always, but storage is needed for the actual storage of the machines that are going to make up the Kubernetes nodes. So depending on where you're creating your Kubernetes cluster or your CAPI cluster, it would depend on the type of storage. So, for example, in AWS, when you provision a virtual machine, it might be creating the storage as an EBS volume. So that is, I guess, infrastructure required for the machines that will then become the Kubernetes nodes. So yes, CAPI is concerned with storage at that level. But if we're talking about the Kubernetes cluster has been provisioned, and then you're installing workloads into that in normal applications, and they use storage, then that's a slightly different use case, and CAPI doesn't necessarily care about that. Some of the providers may have some quality of life improvements, so perhaps the AWS provider will automatically install the CSI driver for EBS volumes, so that the applications you then install can take advantage of that. But that's on a per provider basis. CAPI itself only really cares about the storage required to run the actual machines.
That's a great question and great answer. Good job, everyone. Okay, so we're going to pursue this linear path, which I'm excited about. So, help me just title what it is we're doing right now, so if people join in, they can know what we're talking about. Just by
So I would say it's just I'd call it the provisioning life cycle or timeline.
Okay. Love it. Cool. Okay. So first, create everything in a target environment that isn't a machine, and your infrastructure provider does that, right?
It does. Yeah.
I'm going to make a note of that. Okay. And
So
then now the control plane provider helps make the VMs from here.
yeah, well, yeah. So once you've done that, you signal to CAPI that you've provisioned the base infrastructure. Again, this comes down to the contract. So then core CAPI will then move on to the control plane, and it will, and then the whatever control plane provider you are using will then take over.
Okay, so signal to CAPI that it's complete.
Yeah.
Okay, and then step 2.
Step 2 is now the control plane provider can take over. So whatever control plane provider you're using, because it knows that the infrastructure is ready. So what this will then do is it will create the first of the control plane machines, and to do that, it needs the help of a infrastructure provider. So so again, a bit like the cluster, the control plane will reference a machine template, basically. So this isn't an actual machine; it's just a template of a machine. So it will describe all of the infrastructure specific bits to create that machine. So it might be like the instance type or the amount of memory.
So is a machine template a custom resource definition? Or
yes, yeah. So yeah, this is where it gets a bit murky, I think is probably the best word. So there are templates, machine templates. So they are just as they sound. They're a template. Other things will then use that template and stamp out copies of it. And so there's a couple of places of this done. So we have the machine template. So that's going to stamp out infrastructure machines and CAPI machines. So if you say on the control plane, I want 3 control plane nodes, it will use that template and go, we need 3 versions of this. So it will basically copy them and create instances of those custom resources in the cluster. And the same for Bootstrap configuration, because you need Bootstrap configuration for each of those machines. So this is where the templates come in. And again, this is an overloaded term in CAPI.
So a machine template is not a custom resource definition. It
is.
Okay. It is a custom resource definition that stamps out many custom resources. Right.
Yeah. So,
okay.
Yeah. They are 2 separate custom resource definitions. They've
What's 2 separate ones?
So the machine template and the actual machine.
Yeah. Oh, okay.
So to give a concrete example of this, if I was creating a cluster in AWS, so there is a custom resource definition for AWS machine template,
Okay.
which the control plane will use it. Go, this is the template. So when it runs, it will then say, I'm going to create a instance of AWS machine from that template. And then it actually creates those in the cluster.
Okay. So I'm going to say a control plane creates a first of control plane machines with help of the infrastructure provider using CRDs, machine templates, and machines.
Yep.
Is that correct?
Yep.
Okay. And I'll have to make a note of this later, but I'm using now green stuff to denote CRDs and pink stuff to denote providers. Machine templates. Machine templates and machines. Cool. And we have another question from Kuramaju. So does CAPI have an architecture diagram?
It has.
Yeah, if you want to Google it and give it to me in private chat, I can put it in all of the
I can do that.
all of the chats. Great. Is this the end of step 2?
No. So when the machine is created, we need to then obviously pass in the instructions to do the initialization or the creation of a Kubernetes cluster. So when it's also going to you're also going to create instances of whatever Bootstrap CR it is from the Bootstrap template as well, and when the machine reconciles or the machine is created, it's going to use the Bootstrap data. So there is two parts that are created here from templates.
Okay, so the first machine's created and the machine uses the Bootstrap provider to start the installation. Is that true?
It uses the output of the Bootstrap provider, yes. So
okay.
Yeah.
Oh yeah. Machine. So I am making it a step 3. I feel like it's just semantics about what steps are, and this is the.
It's probably.
And it's doing is beginning the installation process, right?
Yeah, it's basically invoking the command to do whatever is required to do the installation.
So it's doing the whole installation, or it's beginning the installation?
It's doing the whole installation. So the first node, it will wait for the command.
So it's installing the control plane onto the first node.
Yes, and it will wait for it to be ready.
Okay. I'm going to say machine. Yeah. The regulars of the show, I say this all the time, but when I was just for learning Kubernetes, it confused me that the words machine and node and box and computer were all used interchangeably. Yeah. So I'm going to try to say machine this whole time. I think I've already messed it up. I'm part of the problem now instead of part of the solution. Anyway, they're all the same thing. So great. So now we have one machine provisioned, and we have Kubernetes control plane installed onto that one machine.
Yep.
And now you've sent me a link that I can give to Kuramaju and everybody. So
I guess the first link is the concept, so that we haven't talked about how you deploy this, but I guess that gives an overview of, you have a management cluster and you install these things. And the second link is under that top level. There is, I guess, timelines and process flows for each of the type of providers. So a Bootstrap controller should do this, and it's got it as a flow.
Great. So we just put 2 links in the chat. Wonderful. All right. So now we have a machine provisioned, and it has Kubernetes, the control plane, installed onto it.
Yep.
And then there's a signal to Cappy that it's complete, right?
Yes. Yeah. So it will signal machine is ready. At this stage, it does a couple of things. A couple of things in parallel. Then really from here onwards. So probably the best, most interesting thing before we move on to the in parallel thing is, because we have the first machine, we can also create the kube config for that new cluster, and that kube config is created and stored within the what we call the Cappy management cluster, or the Kubernetes cluster that is running cluster API. So you can access, you can get that secret and then connect to your cluster.
So the Bootstrap provider probably does that based on your description of everything?
No, it's the control plane. The control plane provider does it.
Oh, okay. Okay, got it. Oh, yes, okay. So let me control plane. Provides kube config. Or how? Repeat.
So it will create the kube config and store it as a secret in the in the cluster API management cluster, or cluster API Kubernetes cluster.
Okay. I'm going to call it a management cluster.
Yeah, that's what Cappy refers to it as.
And then also for this is wherever Cappy is running, right?
Yeah, it is. Yeah.
Cappy is like, it sounds cute. It's like a cute little character.
Yeah. Well,
I just want to pinch his cheeks.
I was going to say the logo is a bunch of turtles. I think there is a button, so you can see the turtles.
Turtles all the way down.
Turtles all the way down, yeah.
Cute. It is cute. Is that turtle named Cappy?
Good question. I don't know what it was when I ordered it. I don't know what yeah, I'll have to have a look. I'll furiously Google that as well.
Put it on the list. All right, so we have, this is a kind of a side note you said, but now the kube config's created and stored in a secret as a management cluster, so now you can connect to the cluster even with one node.
Yep. So now we're at this point. So then a couple of things can continue on now. Now that we have essentially a Kubernetes cluster, it's only one node, but it's a Kubernetes cluster. So from now on, if you specified more than one control plane node, it will then create new control plane nodes and do a similar process, but instead of, so it will do the Bootstrap. It will create the machine from the machine template. So it will repeat some of the steps, but the actual commands will be different because we're not creating a new Kubernetes cluster. We're joining the existing nodes. So it's basically the same, but slightly different commands that are run on the machine when it's booted.
So the control plane provider will repeat step 3 if needed for however many machines need to get
exactly. Made. Yeah.
Okay. Does it make the worker, even though it doesn't care about the worker and the workloads, will it make the work? They need to get created. No, it just doesn't.
No.
How does that get done?
So now this is where the concept of there's different flavors of how you create worker machines. So was going to say the main way, but that's probably not correct. The traditional way is via something called the machine deployment, and this is a core CAPI custom resource and controller, and that defines a set of machines essentially. So
a set of worker machines.
Set of worker machines, yeah.
Okay. Should I write that down, or is it too soon in the story?
No, because I think at the moment, so yeah, I think we're at that stage now. So this one where it's creating the additional control plane machines, and where it starts provisioning the worker machines, these two happen in parallel.
Okay. Okay, I'll write parallel. And so it's not, who's in charge of making the worker nodes get made? The machine deployment is in charge, and so do I that's the subject of my sentence, machine deployment.
Yeah, so the machine deployment owns it from a core CAPI point of view, but again, it's a infrastructure agnostic representation, and that relies on the infrastructure provider itself.
Okay.
So in a similar way that the control plane, but it applies it to the machine's deployment.
So the infrastructure applies machine deployment custom resources to make worker nodes.
So okay. So the machine deployment will result in machines. Well, it's a bit like I think of it like a deployment in Kubernetes. So a deployment will create a replica set, and that replica set will then create pods. So this is very similar to machine deployment. So machine deployment will create a machine set, and the machine set then will stamp out machines. And all of those machines, and these are all CAPI, core CAPI custom resources. Those machines will reference an infrastructure machine, because again we have this concept of a general or logical representation of a part of a Kubernetes cluster, and an infrastructure specific representation that does all of the infrastructure specific configuration and work.
So infrastructure provider makes a machine deployment custom resource, CAPI core custom resource, which makes a machine set, just like a core CAPI custom resource, which makes the worker machines, which is also a resource.
Yeah, which makes infrastructure machines.
Which makes one or many
machines.
Wait, what did you say?
Yeah.
Okay.
No, yeah.
Okay.
One or more machines, which references a.
Let's say worker machine. I'm going to add the word worker in there. I think it's important. Okay. Cool. And now we have a cluster.
Yeah, after so there is an infrastructure machine as well, but yeah, then you have a cluster, basically. Yeah.
There is an infrastructure machine.
Yeah.
Is that like management related?
No, so the infrastructure machine is the infrastructure specific configuration of a machine. So the machine here is like a logical representation of a worker machine. But we still need to create an infrastructure machine. So we still need to create a VM or a physical machine. So this is where the infrastructure machine comes, because it has to have infrastructure specific configuration and also infrastructure specific controller that does the actual act of provisioning that machine.
Okay, that makes sense. So, but these worker machines can get made first before the infrastructure machine steps in?
So the CAPI machine gets created first. Yeah, and it references the infrastructure machine. So they're stamped out.
Okay.
Yeah.
Yeah.
You need both. So yeah, you need both.
Do you feel like how can you help me capture it here or does it need to be captured?
I think it probably does. So I always think of it as like I always think of it very similar to pods. That's how I would describe it. So we have the machine deployment, which will create machine sets, a machine set, and that machine set then creates machines, which then reference an infrastructure machine. And so you have this tree. And the reason why it's done that way is for exactly the same reason as deployments, deployments in replica sets and pods. So you want to ensure you have a specific number of machines, but then you also want to perform operations on those machines. Like if you want to do upgrade, you want to do a rolling upgrade of those machines because you've changed a configuration option on it, like the Kubernetes version or maybe some other property. So it allows you to then have that point of orchestration, just like deployments.
That makes sense to me. So then when you say an infrastructure machine, does the word infrastructure mean infrastructure provider? Are we relating to this? Okay. So somehow within this infrastructure provider custom resource, there is an idea of a machine that's been defined.
Yeah.
Okay.
Yeah, so you often, an infrastructure provider will have what we call an infra cluster custom resource and an infra machine resource.
I thought it was 1-to-1. Oh no, not again.
Yeah.
So let's finish the thought. I thought the infrastructure provider had only one custom resource.
No, so it can have multiples, but when we talk about a 1-to-1, I should explain that better. So when I talk about a 1-to-1, so there is a CAPI custom resource for a particular part. So we have a cluster or a machine, and that is a 1-to-1 for a custom resource in a infrastructure provider. So cluster, infra cluster, which could be AWS cluster, and machine and AWS machine. So that's where the 1-to-1 or the pairing comes in.
Okay. So the pairing is there's several CRs that fall under provider, but every provider CR has a equivalent CR in the CAPI ecosystem.
Yeah.
Okay. So what I'm going to try while I restart, I'm going to restart my browser first and hope that fixes it. But meanwhile, we're going to go, I'm just going to, let me see if I can turn on my camera. This is going to be so unflattering, but let's just do it. Here we are. Haha, hello. You can at least see me that I'm here over here while I go restart my stuff. Let's you can get like the full like behind the scenes view of all the stuff I have going on. Let me first try restarting the browser. If anyone out there watching this or the recording ever knows what this problem is or how to troubleshoot, please contact me. Thank you.
Yeah, I just had a look. I'm not sure the turtles have a name, but I could be wrong.
Okay, now I'm full. Oh, I don't like being so large on here. Let's at least be even sized. Okay, I can hear you. You can maybe hear me from my iPad.
Yep.
Cool. So I'm still here. Nope, and I still have a problem. So I have to restart the whole machine. So CAPI The turtles don't have a name, even though the word Cappy would be a perfect name for a turtle, especially one that's wearing a little hat.
Yeah, because it's, I guess it's, Vippy is a thing, isn't it? And but I've put the link in the chat, so if people want to buy
nice.
the plushie.
Oh yeah,
they can do.
I will share it. So I have this little iPad in the corner now that we're getting all the backstage view, and this is how I highlight. I use this iPad to highlight comments, so without having to bend over to get to the laptop that's actually running the show. We could probably still kind of continue the conversation.
Yeah.
This is a funny. I kind of Let's do this. So with these 6 steps that we just talked about, do you feel like the story of the provisioning timeline has been told?
Yeah, I think so. I think it has. There are some more advanced things that can be done, but that gives the general flow. It's slightly different if you were provisioning like a managed Kubernetes service, because it doesn't necessarily have control plane machines, but it still has the concept of a control plane. So you will still see a control plane provider used.
Okay.
So it's largely the same. There are also other ways to create worker machines. So we mentioned machine deployment. There is something called the machine pool, which is a pool of machines. That is basically its job is the same to create worker machines, but it does it in a different way. And this is machine pool is still experimental. It's been experimental in cluster API for quite a while. And the idea is with the machine pool, and the way this is subtly different is it's a pool of machines, and that pool of machines can be backed by like an infrastructure specific service in whatever infrastructure you're using. So for example, if you're targeting Azure, it will be backed by virtual machine scale sets, or in AWS ASGs, and those infrastructure services can scale up and down automatically. So instead of like a machine set which has a fixed number of replicas, machine pool starts to introduce the concept of a scaling set of worker machines. And again,
I want to interrupt you to ask. There's just a little bit of space left on the board. Do you think it's best spent on writing down these extra custom resources, or is there something else you think would be better to document?
That's a good question. So I think it's just a variation on the theme for these custom resources. I guess one other thing that could be worth covering is the concept of cluster classes or cluster templates, which is cluster classes is a fairly new feature in cluster API. But the idea is often when you create child clusters, you want to stamp out copies of the same type of cluster. So you might have we talked about environments. You might say have a template for like a development cluster or production cluster, or maybe some other type of cluster, but you want to create instances of these. You don't necessarily want to create all of the YAML every single time. So this is where things something like cluster class comes in, where you sort of define a class of a cluster, so a shape of a cluster, and then you stamp out instances of it.
That makes so much sense. Yeah, like different teams need different development environments, but they don't really need to have any variation between them. So
and it's almost like template, cluster templates, which Cluster API also has. So that was the original way of doing this. Cluster classes like templates on steroids, because you can also define ways in which that template can be customized, which would then slightly alter the resulting definition of your cluster. So you can actually say, well, this is my class of a cluster, actually, but when you create your instance of it, you can change this variable.
There's some knobs. Your template basically doesn't have knobs, or
Yeah,
It can be harder to maintain probably the differences between a template. Yeah, that makes a lot of sense.
And it's really, really super useful to allow that customization. Because cluster templates were fairly rudimentary. They just had tokens in them, and you just replace those tokens. Whereas for cluster class, you can actually turn features on and off. You can apply patches to the YAML and do all of this stuff. And the really cool thing is you can also define variables. So these are obviously things to a user that you could set, and they affect the outcome. But you can build tooling on top of cluster classes because it has this well-defined variables. So actually, if you're building like a UI or something, or any other custom tooling around Cappy, it's so much easier to do than if you were using templates.
I think maybe the mention of the UI answers my question, but there's so much talk right now about platform building or the developer persona or abstracting away these complex infrastructure details from a developer who just needs to hopefully have self-service access to provision a cluster. So is this not cluster template, but what was it? Cluster
class.
Cluster class. Is this the key to that? Probably wrapping that in a UI might be how.
Yeah, I think so. I guess actually, when you're dealing with cluster classes, you still need a certain amount of knowledge. But yeah, if you wrapped it and just allowed customization of the variables, and maybe gave it a cluster name and the variables, then yeah, that's all you need to actually expose. And you could do that via nice UI or whatever tooling. So the whole self-service model is a lot easier, while still having control over the actual cluster definitions as a platform team. It really helps in that type of scenario.
Cool. Hold on, please. I think I can get the other thing back. I think we're ready. This is, let's see what we got. Cool. And let me. Okay, then let's get this thing off the screen. Move from the screen. Make the whiteboard big. Oops, that's not it. Yeah, it is. Yeah, we did it. We're back. That actually, yeah. Thanks for bearing with me through that. I think we remained productive that time. I'm learning. At least if it's going to keep going wrong, I'll get better at it being wrong. All right. So we have this little space. I do want to make a legend where this means it's a provider. And if it's a green box, it means it's a Cappy Core custom resource. That's a lot to write. So it's a provider. Yeah. Okay. And this is okay. So that defines that. And then if we could there's maybe room to put a quick reference to technically all three things we've talked about: the machine pool, the cluster template, and the cluster class.
Yeah, sounds good.
Okay, so let's make some space. And then we'll do a recap. Other Cappy Core CRs. CRDs, really. Excellent. So other Cappy Core CRDs include, we talked about, let's do cluster template, which is old.
Yeah, and actually the cluster templates weren't custom resources. They were just textual templates with tokens in that got replaced.
Okay. Well, then I think they're not going to make the board then. What do you think about that?
Nah, ditch them.
It's our world, Rich. We make the rules here.
Yeah.
Cluster template is out. Okay, so then let's talk about machine pool. And a machine pool enables machines, like enables cloud providers to be able to do machine scaling. Is that correct?
Well, it enables you to create worker machines using, I guess, a cloud provider's specific service, and that normally relates to some sort of pool of machines, auto-scaling service. So auto-scale groups or virtual machine scale sets.
Oh, I can fit all that in this space. I got it.
Or maybe we could use the acronyms like ASGs or VMSS, I think.
So machine pool enables you to make worker machines via your cloud provider.
Yeah, and it's a pool of machines. So traditionally, you wouldn't have individual machines out the back of this from a CAPI point of view. You just have a pool of machines, and you say, I want a minimum of 1 machine and a maximum of 10. Whereas like with a machine deployment, you say, I want 5 machines. You actually say, I want 5. Whereas this with a machine pool, and then with a machine deployment, you have individual machines, and you can reason about those. Whereas with machine pool, you don't have any of that. You just say, I want 5 machines, or I want between 1 and 100, and that translates into whatever the service is behind the backs up.
Cool. So I understand what you're saying, but I think maybe just to tell the story, we don't need to include that particular bit of information. And like the bottom line is that it scales. It enables many different scaling strategies.
Yes.
Okay. Maybe just enables scaling because I'm running out of room. Enables scaling strategies. I like that because cool. So that's machine pool, a very oversimplified machine pool. And then the other one we talked about is template class.
Cluster
class.
Yeah, cluster class.
And cluster class is a way to stamp out clusters with customizable knobs. With customizable
exactly.
Characteristics.
Yeah, exactly.
Stamp out clusters. That can then have customizable characteristics.
Yeah, that's a good way to describe it.
Excellent. This is the board is full, and I'm going to go through and recap everything. But how do you feel? Do you feel like your technology has been represented well? Are you? It's a funny show because we can't really exactly plan how it's going to go.
Yeah, I think it tells a story. For sure. That there is more to Cluster API, but I think this captures the essence of it.
Okay, wonderful. And do you want to say a word about what we didn't cover?
Well, I guess the single biggest area where Cluster API is moving into is so we do the provisioning, but provisioning sits in a wider ecosystem normally. So there are things like runtime hooks, so that you can hook into the provisioning lifecycle and perform custom operations, whatever they may be, or maybe you want to customize it as part of the provisioning. So that is the one area. And I get a few other areas that we are discussing as general trends is making the actual installation of CAPI more GitOps friendly. So there is something called the CAPI operator, because actually to create your management cluster you had to use a command line tool that would install CAPI and stuff like that. But if you're going full GitOps, there is something called the CAPI operator.
Cool.
What else could I say?
I like that idea, full GitOps.
Yeah.
Like hardcore, full GitOps, yeah.
Yeah, I think that's probably it. I've probably missed a whole bunch of stuff. But yeah, and probably just to reiterate as well is there this concept of core CAPI and providers. You know, providers are an essential part of CAPI. They do all of the infrastructure interactions, and help is needed on core CAPI and on all of the providers. So if anyone's ever interested, say, get involved.
Yeah. Well, I guess one thing we talked about, and I didn't capture because of the technical details, is that the one-to-one provider to CR relationship, clarifying.
Yeah, so I'd say the main one there is cluster and the infrastructure cluster.
Uh,
And,
I was gonna write, for example, infrastructure machine.
yeah, that's a good one as well.
Happy, okay.
Yeah.
Because that's what we talked about here. It's
Yeah.
not very original. Yeah. I'm gonna write through where my face belongs.
Yeah.
I can kind of talk over here. Example, infrastructure. Machine. To CAPI core machine. Excellent.
Yep.
Cool. All right, so let's recap. Feel free to chime in if I'm saying something wrong or something you want to clarify a little bit. And I'll also ask you at the end if there's any clarification you want to do. So, long ago, in a lands before cluster API, the cluster lifecycle management was very difficult. Different tools might be needed for different cloud providers if you want to provision infrastructure in different places, so the whole multi-cloud world was difficult to manage. And it also was not declarative, so it was bad for GitOps and probably relied on scripting. So Cluster API came into the picture. It's a Kubernetes sub-project that uses Kubernetes custom resources and controllers to manage the lifecycle of Kubernetes clusters. So Cluster API cares about 4 things. Base infrastructure, so for example, VPC, networking, security groups, that sort of thing. It cares about the infrastructure required for Kubernetes, so that encompasses physical or virtual machines. It encompasses how to install Kubernetes on top of those machines. So you use the word bootstrap. I didn't want to assume that people know that word, and it encompasses how to bootstrap Kubernetes machines. And then it's concerned with day 2 operations. So what's your current state of the cluster? What's the current version of Kubernetes you're using? Whatever else. Great. And so we also talked about what Cluster API supports. So we can think about that under 3 umbrellas. Cluster API supports target environments, so all major cloud providers are supported, plus bare metal type stuff with all the those bare metal aren't really providers, but bare metal tools, we'll say.
Yep.
It supports different Kubernetes flavors, so that by flavors we mean like a cluster created. We also talked about this kind of like this when we talked about different tools that you can use to create a Kubernetes cluster. So by flavors, we're talking about Kubernetes clusters created with kubeadm, or with K3s, or with EKSD, and the D is for distro. I wrote because I've never heard of EKSD before, but I assumed the Kubernetes flavor can also relate to KOps or RKE2, and these examples we talked about before in terms of what tools are used to install Kubernetes.
Yes, except for KOps.
Okay.
Mainly because that's a provisioning tool in itself, and does provision infrastructure and things like that. So,
okay.
Yeah. So,
Okay.
But you could, in theory, you could wrap it that way. I just don't think you would. But yeah.
Nice. Good note. And then a Cluster API also supports different tooling. So once you get into vendor-specific clusters like Tanzu or Rancher, D2IQ, which I have no idea what that is, OpenShift or EKS Anywhere were the examples we use for that. And finally, I gave in. For a while, I was trying to write cluster API every time, and we just started saying CAPI instead of cluster API. So I gave in and made a big thing, cluster API. When we say CAPI, we mean cluster API, which I learned today, just now. So core CAPI is what we're calling the essential cluster API custom resources. So I didn't understand when you first introduced this idea of core CAPI. It's necessary to talk about because we need to make a distinction between core CAPI resources and custom resources related to CAPI that are being provided by the infrastructure providers.
And the other provider types, yeah.
And yes, by outside providers that aren't a part of the CAPI project.
Yeah.
So that's the distinction we made. And in this board, to try to keep things organized, whenever I talk about a provider, what did you call it? The provider resource? I wrote it in pink. Yeah.
Yes. So, we said provider custom resource, didn't we?
Yeah.
And normally most of the ones we talked about were infrastructure provider resources, but I guess it could be any of the other ones. But I think from the list, I know we've got some Bootstrap there as well. So yeah.
Yeah. So whenever we talked about a provider custom resource that's not part of core CAPI, I wrote it in pink. And whenever we talked about a core CAPI custom resource, I wrote it in green, and it always has a box around it. So we tried to stay organized in that way. So first we talked about a core CAPI resource called a cluster that represents a cluster as a whole. So that it talks about the general configuration. It's also infrastructure agnostic, but then it's going to reference infrastructure in the other CRs that it uses, which are likely to be provider CRs. I guess they're both kinds of CRs, but the provider CRs is where the infrastructure specific stuff comes in. So then when we talked about outside providers providing custom resources to CAPI, we talked about providers, and a provider is a custom resource definition plus a controller. And a provider can encompass several custom resources. One provider can encompass several different custom resources. So that's something I'm just wrapping my head around at the end. So that, for example, an infrastructure machine is related to a CAPI machine. And that's a one-to-one resource. So all of these provider types are their own separate projects. They're not a part of CAPI, but they're made up of CAPI compliant CRDs, and they adhere to a core CAPI contract. Try to say core CAPI contract 3 times fast. So all 3 of these provider types have those things in common. So we talked about the infrastructure provider. So a great example of that is an AWS provider or a GCP provider. There's also a Bootstrap provider. What a Bootstrap provider does is it generates instructions on how to create a Kubernetes cluster or how to add a machine to a Kubernetes cluster. I'm trying to say machine all the way through this and not switch the word for node or whatever. And then it also formats commands so they can be executed by whatever tool sets up the cluster. So it generates the commands, and then it also knows what tool you're gonna use, and so it formats the commands so the tool can read it.
Yeah.
And so the examples we gave are Cube ADM, K3s, RK, E2, KOps, and more. And then the third type of provider type is a control plane provider, which is concerned with the Kubernetes control plane and lifecycle of the control plane nodes. So CAPI doesn't care about workloads. That's not workloads. It cares about worker machines, but not workloads at all. So the best way to frame this conversation, I decided, and you went along with it, is as a provisioning timeline. So we came up with 6 steps here. So the first thing is that the infrastructure provider creates everything in a target environment that isn't a machine. And then a control plane provider creates the first of the control plane machines with the help of an infrastructure provider. And it's using CAPI core CRDs, machine templates, and machines in order to make those machines. So then the machine that got created, so in our story so far, one machine has been created, and that machine uses the output of the Bootstrap provider, so those formatted commands, to install Kubernetes control plane onto the very first machine. And so now we have our very first, technically if we only want one machine, we have a Kubernetes cluster at this step. And then it's going to signal to Cappy, okay, we have our machine. Next up, the control plane custom resource, where'd it go? Right here. The custom resource control plane creates the kube config and stores it as a secret in the management cluster. We didn't mention the management cluster yet, but Cappy has to be running somewhere enabled in order to be able to make this, to be able to doing all this.
Yeah, exactly.
So that creates a secret in the management cluster, and it stores the kube config file and how to connect to that kube config. So now you can connect to your one node cluster. But if you want to add additional nodes, that happens in step 5, where the control plane the provider repeats step 3 for as many times as necessary to make as many control plane machines as requested. And then in parallel to that, the infrastructure provider makes a Cappy core resource called a machine deployment. So we talk here about machine deployment, machine sets, and machines, which we can think of like a Kubernetes deployment, a Kubernetes set, and a Kubernetes pod, a Kubernetes replica set, and a Kubernetes pod, just to separate out those different concerns. So machine, we think about it as a deployment level in case you want to make a change across all machines, where you could roll out that change across machines. We talk about a set level because we have some sort of the machine sets, making sure the right number of machines that you've defined is running at any given time. And then the specific machine spec is going to be within the machine custom resource that's part of core Cappy. So the infrastructure specific, the infrastructure provider makes a machine deployment, which makes, just like Kubernetes, makes a machine set, which makes a machine, which then references an infrastructure machine. So there's a CR called a machine within the infrastructure.
Yeah, I think there's probably a slight change we'd have to make to number 6.
Okay.
So it actually starts with the machine deployment. So the machine deployment creates the machine set, which then creates the machine, which then uses an infrastructure machine. So that first, that's just that first little bit. Yeah.
Excellent. That's the easiest kind of change to make when I just have to erase something. Love it. And that's how the worker nodes get made. So now we have a full Kubernetes cluster with everything we've defined, and we can connect to it, and we can add workloads to it, and we can add our own other custom tooling to it.
Yay.
We did it. Good job, everyone.
Yeah.
So there are also hooks in this provisioner lifecycle, and that's something we didn't get to talk about. But if we want to trigger other things, we kind of talk about it because we say signal to Cappy that it's complete, and we signal to Cappy machine is ready. Like, we can guess that those types of things would be ways to hook in if you have other things you want to be running in parallel. Rich, what's an example of something you might use a hook for in a provisioner lifecycle?
So one example is so if you're talking of like a virtual scenario, like where you're creating machines, you might need to, as before you provision the actual cluster, you might want to create a VLAN or something. So maybe you have a software-defined network. So you want to make sure that is created first, but it's part of the provisioning flow, so it can call out to do that. There is actually, as part of those hooks as well, an interplay between the hooks and the cluster class. So maybe you want to call out to another service that gets some of the information for your cluster class when you're stamping it out. So that's the type of scenarios. Or maybe you just want to hook into some sort of alerting system to say, hey, this cluster's being created. Some type of organizations love to register the fact that a cluster has been created in some sort of asset tracking system thing. But it allows all of those type of custom integrations that you can't think of, but that generally do exist in a provisioning flow. Yeah. I did think of something else when you
Yeah.
said Cappy doesn't care about workloads,
Uh-huh.
and it generally doesn't. But there is something called this is new. There's an add-on provider type,
Uh-huh.
which basically means you provision your cluster, but there is always something that needs to go on that cluster first, whether it's
Yeah.
like a GitOps agent like
Yeah.
Flux or Argo
Uh-huh.
or a
Policy
CNI.
management.
Yeah,
Mm-hmm.
so that this is where like the add-on provider comes in, and so
Mm.
its role is just to install those first few things on the cluster when the cluster has been provisioned. So generally, it doesn't care about workloads, but it can install those initial workloads if you want via an add-on provider, which is good.
Excellent.
Yeah, that was didn't want to forget that.
Yeah, that's cool, and it makes a lot of sense that would be part of Cappy. So then we had a little teeny bit of space, and even though there's a lot we didn't get to say about Cappy, it does a lot more but we got the crux of it here. But within our extra little bit of space, we talked about a core Cappy resource called a machine pool, which enables you to make a pool of worker machines where you don't define the actual number of machines, but instead you say like no less than this, no more than this. And then a cloud provider can, with this machine pool, can do different scaling strategies. Excuse me. So that's one custom resource that we talked about. And another one is a cluster class. So we want a way to stamp out entire clusters, and previously that had been done with a cluster template, which is just text. But now we have evolved, and we have this cluster class, so we can stamp out clusters that then have customizable characteristics.
Yep, exactly.
And that's Cluster API. That's Cappy.
Yep.
We did it.
Yeah.
Excellent. This has been really, really fun. You said you watched some other episodes, but I'm not sure if you watched them to the end. The way we say goodbye is by doing a little dance together. Not a particular one. I'm just going to replay the intro music, and we'll shake our shoulders a little bit. There's not much of you that shows, yeah.
Yeah.
So we're gonna say, do you have any parting words, or does anyone have any questions before we dance it out?
No, fantastic.
Yeah, thank you so much, Richard Case, for being the guest. Thank you everyone who came and watched and who asked questions and who watches the recording. I really, really appreciate your time, and thank you. Let's dance to my brother's song that he wrote for the show. Here we go. Goodbye. Come on. Yeah, there you go, Rich. You got it. Ooh, Cappy the turtle's dancing too. Yeah. Goodbye.